today for today's class. Alright, so last week we looked at module 4 chapter 4 module 3, where we talk about our infrastructure. So the aim of the objective of the module is to understand common data center terminology, so that you understand what are the terminologies used in the data center and how a data center operates. Then we also talk about the cloud, and then from our discussion, you should be able to differentiate between what a cloud is and what a data center is. And of course, what we are going to be doing today is today we are going to be finishing the last objective, which is to identify secure network design terminology. Alright, so we talk about data center, and data center are like buildings where organizations store their data. So we talk about components, things that you can find in a data center. You see, when you get to a data center, you see what we call closet, where servers, printer, network equipment, cabling, and other things are located. And then we talk about the HVAC environment, because the data center generates a lot of power. So this leads to it uses a lot of power. The data center uses a lot of power. So this makes it to generate a lot of heat. And then there is you need to make sure that all these devices that are in the closet are at a particular temperature. So the HVAC system helps us to regulate the environment so that it will not be too cool and it will not be too hot. So that's another component. And then we have the fire suppression to make sure that if there's any incident of fire, because all these are electronic devices, and there can be a spark that can lead to a fire incident, so that we have a fire suppression system in place to put out the fire. And then of course we have the power system too, because all these are electronic devices, they need electricity to run. So we have the power system that makes sure that there's continuous power, that is so that these devices will not go off at any moment, because they are supposed to be running 24 hours in a day, 7 days in a week. Alright, so we talk about all these those are the things we talk about. And then we also talk about redundancy. There's a need to have a power redundancy in the data system, because you can't afford an outage, because your data, you need to have access to your data 24/7. And then there's a need to have a redundant power system, which includes a combination of a generator set using power from the grid, and then of course using UPS and battery to ensure that there's full redundancy. Even though when you are switching from one source to another, you still ensure that there's still power running in the data center. So that is the need for this redundancy. Then we talk about the cloud. So the cloud is a substitute for a physical data center. So if you cannot afford to build a physical data center, you can subscribe to the cloud. So the cloud is being managed by a cloud service provider who already have this infrastructure in place. They have their data center in place, and then they are now leasing it out to you, and then you can subscribe to it based on your need. So we have different deployment. This the architecture of the cloud. These are the features of the cloud. It provides a broad network access. It provides rapid elasticity. You can upgrade your bandwidth in the cloud. For example, if you are on a very low bandwidth and then there's a need for you to increase your size or your bandwidth on the cloud, you can just make your payment and then it increase. And then of course it's a measured service, so it's what you use, that's what you're going to pay for, or what you pay for is what you're going to use, as the case may be. And it's an on-demand self-service, so the service is already running. Okay, so it's just for you to make payment, you demand for it, and then you can start enjoying the service of the cloud. And then we talk about resource pooling, whereby the resources of the cloud is already on the cloud, and it can be offered to different customers. So for example, different customers can be on Amazon. You are going to pull from the same resources. You are going to pull from the same data set. You are going to pull from the same server and other stuff like that. So It gives us an access for resource pooling, and also when you need to collaborate, you can also decide to maybe share your data with an organization that you wish to share it with, as the case may be. And then we have the deployment model in the cloud, okay, which are the software as a service, the platform as a service, and infrastructure as a service. So I give us an example last week where I told us that the best way to explain software as a service is that the cloud service provider gives you everything, right from the infrastructure to the application you are going to use. The only thing you are going to bring in is your data for you to be able to use that infrastructure. So if you can remember, I referred to our laptop, for example, as a cloud service, for example. So if you are given a laptop where you have operating system on it, you have data on it, you have internet on it, you have been given internet, it has been connected to the internet, and then they will give you an application to run. For example, if you need to subscribe to Office 365 or Microsoft Office or Excel, as the case may be, you already have those software and everything is intact. The only thing you need to do is just to open the Excel, create your file, create your document, type your document, save it, print it, do whatever manipulation you want to do. So you have the software already installed, and then the only thing you need to do is just to log in and start using it. So that is a typical example. That's just an analogy for a software as a service. So, and then we give us different example when you use your for example, your Google Drive, your OneDrive. When you open your when you open your Google Drive, you can see that you can do, there's the Google document, there's Google Sheet, there's Google Form, all those things. You can use them. The only thing you need to do is just to log in and start using them. Okay, so that's an example of a software as a service. Also, your Netflix, your YouTube are also good example of software as a service. You don't need to create an account. For Netflix, you just need to pay, and then you can start watching your movies. So you don't need to even download them, as the case may be. So, and then the other deployment model that we talk about is the platform as a service, whereby the cloud service provider gives you the hardware, gives you some level of virtualization. You have your operating system also on that particular cloud service, and the only thing you need to do is just to build your own application or host your application on the cloud service provider. So we give an example of Amazon Web Service, right? We give an example of Amazon Web Service, or maybe when you go to all these hosting website, all these hosting site, where you can buy your domain. You see that they give you an operating system or whatever. Then you can now decide if you want to use WordPress to host your website, or you want to write the code by yourself, and then you upload it. So that's a typical example of a platform as a service. And then I give you an analogy whereby I give you a laptop that is having an operating system, maybe Windows or Linux as the case may be, and then you are asked to put your own application on it. So maybe you build an application, maybe a calculator or a software that you can use for maybe HR or your loan, whatever, your expense management, whatever application. You will be the one to build it, and then you can now start using it on the system. So that's an example of a platform as a service. And then the last one is infrastructure as a service. The cloud service provider only gives you access to a virtual machine. So we call it a virtualization. So it's empty. You don't have anything on it, right? So you are the one that will now come and install your operating system on that particular virtual machine. So you can install Windows, you can install Linux, you can install Windows Server, depending on whatever you want to do in that particular environment. And then after installing your operating system, you can now also build your application or install your application on that particular cloud. So that's a typical example of an infrastructure as a service. And then I gave us an example of a laptop also that doesn't have, we just give you a plain laptop, there's hard disk on it, Okay, there is you need to charge it, and then you need to now install maybe Windows operating system or Linux operating system before you now install your application on it. So in all of these, they all have their advantage, and then they all have their strength. So for software as a service, you are not responsible for any update, you are not responsible for any patch. It's been done by the vendor. The only thing you need to do is just for you to use it. Everybody have the same version. So far you are on the latest version. So for example, if you are for example, you are not responsible for releasing patch for your WhatsApp. You are not responsible for releasing movies on Netflix, right? So the only thing you need to do is just to log in and then watch movies that has been uploaded on it. So, and whoever has also paid for that particular Netflix, we also have access to the same. So far you are at the same level of subscription, they are also going to have access to whatever you have access to. Then whereby for platform as a service, you will be responsible for some level of security update and stuff, maybe for your application only. Then for the operating system and others, the cloud service provider will be responsible for it. So you share the management for platform as a service. But in the case of infrastructure as a service, you are responsible for everything. You are responsible for the security, you are responsible for the updates, you are responsible for the patch and other things like that. And then we talk about the types of cloud. Then we talk about, that's where we talk about the public cloud, the private cloud, the hybrid cloud, and the community cloud. So the public cloud is the one that everybody can subscribe to. It's open to the public. You just need to either use it either for free. We have the ones that are for free, like the Google Drive that we are using, and then we have the one that is paid. So there's Google Premium, where you are asked to pay, I think, around $8 as an individual, and then for a business, they also have their charges. The same apply for Microsoft, the same apply for Amazon. And then we have a private cloud whereby an organization can decide to build their own data center and then use it for their own activities. So that is an example of a private cloud. Then the hybrid cloud is when an organization combines the use of a private cloud which they have, and then they also use some of their services on the public cloud. Maybe they host their website on the public cloud, or they test some application on the public cloud before they now move it to their private cloud. And then so that's an hybrid. And then finally, the community cloud is a particular cloud that serves organizations with the same mandate. So for example, you can have a cloud for universities, and then only universities can be able to subscribe to it and use it. So it can be public, it can be private. But what makes it community is that it's used by organizations that do similar things. So maybe banks or governmental organizations. So that is that about cloud computing. And then we talk about a managed service provider. So managed service provider is an organization or a company that provides that manage information assets for another company, or helps that you can outsource some of your information technology services to. So for example, if you want a payroll system and you don't want to build it, you can maybe use Zoho, or you can use we have or Salesforce. So you can decide to use all those managed service provider. And then also I think a good example is also all this MSSP, managed security service provider, where you can, if your organization cannot afford to build a SOC or have a SIM, you can outsource it to another organization, and then they will help you to manage it. You pay, they will give you a subscription that you make payment, and then there will be agreed SLA, which I'm going to also review now, and then based on that SLA, they will provide services to you. Right. So, and then you can also have an organization to manage your in-house IT infrastructure. So for example, you have a data center and you want one company to manage the power for you, you want another company to manage the HVAC system for you, you want another company to manage the cleaning of it, to make sure the data center is neat. So you can give it to managed service providers. And then when you are outsourcing anything, there need to be a service level agreement, or SLA. between your organization and the organization that you are outsourcing to. So the service level agreement is just like, it's like a legal contract or a rule book that states all the level of engagement in the service. So it states this type of service. So maybe they'll provide service to you for 10 hours, for 12 hours, for 24 hours. Everything is going to be stated. How many level of staff are they going to dedicate to you? What is your response time if you escalate something? How long will they reply to you, and other stuff like that. So that is what an SLA does. And then okay, so this is a list of what an SLA does, and etc. There are many other ones: data security, privacy, how they deal with your data, how they deal with what are the processes for change management, what is the exit strategy, and other stuff like that. So that is what a service level agreement will do for you. So, and that is where we ended our classes for last week. So this week or today, we are going to be looking at network design. So all those you are already in an environment, you are already working. So let's assume you're already working in an environment as a cybersecurity analyst, or as an IT personnel, or as whatever you are working as. Okay, so this will give us an insight onto how of the objective of the network design, how it satisfies data communication requirements, which also result in efficient overall performance. So for you to be able to have efficient overall performance, so that means you need to make sure that our three objectives of cybersecurity is met. That is confidentiality. Data should only be available to who is meant for. Integrity. Data should only be only people that are only authorized personnel should be able to modify data in an authorized manner, right? Because even authorized personnel can modify data in an unauthorized manner. So it's very important to make sure that authorized people are only the ones that can make modification, alteration to a data in an authorized manner. And then the last one is availability, to ensure that data is available to authorized user as at when needed. Right? So how do we achieve all this? How do we achieve integrity, confidentiality, and availability in the organization? There are a whole lot of methods that you can use. So one of the key methods is what we call a network segmentation. So what is network segmentation? Remember, when we are talking about switch in our class last week on Saturday, when we talk about network security and network devices, I told you that a switch can be used to achieve what we call a virtual LAN, or to make sure that you separate a network. Okay, but that is not where we are going to. We're going to talk about subsequently, but this is quite similar to it, but the only way it's different is that this is mostly done at the network level, probably at the router level. So what we have here is a network. Okay, this can be physical and it can be virtual. It can be different branches and it can be in the same branch. It can be in the same building and it can be in different building. But what this is trying to show us is that we have the network has been broken into chunks. So we can see 2 here. It can also be like 5, it can be 10, it can be 20, it can be 100, it can run to thousands depending on how large the organization is. But what network segmentation means that this segment, so for example, let's assume this is IT department and this is HR department. Where's my marker? Okay, where's my laser pointer? So let's assume this is an IT department and this is an HR department. Even though they are on the same network, right, but they are kind of isolated from each other. Okay, so what makes it isolated now is that, so why this is isolated now is because now, if for example there's an attack on this section of the network, right, it will be difficult for it to jump into this part of the network because it has already been separated. And this is achieved mostly by the use of firewall. So you can see we have a router here. This is a symbol for a router. Once you see these 4 signs pointing like this, this is a symbol for a router, and this is a symbol for the firewall, and this is a symbol for endpoint. So there can be a lot of things in between this. But as you can see, this is a network that has been divided. This is another network that has been divided from it. So with the help of this firewall, So if by chance this particular HR department, so let's assume someone in HR department has clicked on a link that can cause ransomware, for example. So if this ransomware is attacking all the system in the HR department, it will not be able to flow to other networks. So we can see one here, there can be another one, there can be procurement department, there can be operation department, there can be whatever, security department, whatever department. So the advantage of this segmentation is that the network is isolated, right? So if there is any attack between these particular devices, it will not be able to flow because there's no direct communication with them. And if there's any need for system from these particular places to communicate with these particular devices, that will be that the rule has been allowed in this firewall and also in this firewall. So if the rule for communication is allowed in this firewall and is blocked on this firewall, the communication will not flow, right? So that is the essence of segmentation. So the network are isolated from each other, right? And then if this part is being attacked, the attack will not be able to move to this particular side, right? So that is how a network segmentation, that is how it works. Okay, so another way network can be segmented is through a virtual local area network. Remember, I told us that this can be achieved with a switch. Okay, so this is a graphical illustration of a switch. This is what a switch, this is why you can represent a switch. All right, so even though the switch, it can be in the same rack and then you run cable to them. Okay, but it's possible for you to have a separate, you can create a LAN inside that, you can create different LAN inside that particular switch. So that is called a logical segmentation. So remember, this one is a physical segmentation. They are in different location, right? And then they are connected with a firewall, and then a router connect them together. But they are segmented by different firewall, and then they can connect together through a router or a switch. Okay, and then in this case, for virtual LAN, for a virtual area network, it is virtually segmented. This whole system can be in the same office, right? But maybe you have different desks. You have HR desk, you have IT desk, you have, maybe it's a small organization and you have maybe just 20 system in that particular place. So you can put 5 on the same network, put another 5 on the same network, put another 5 on the same network, but all of them will be connected to the same switch. But because you can configure a switch, right, a switch can be configured, so you can create virtual LANs from the switch, and then logically they will be on separate network, and then all the network in this device will be able to communicate with each other. All the device in this network will be able to communicate to each other. But devices, the two virtual LANs will not be able to communicate directly unless you configure them, and then you now you want them to be able to communicate, and then you can now give them some limitations. So maybe you can say, okay, you have access to one of these systems, you can have access to, depending on how you want to set it. But the whole essence of this is to create segments of network that are isolated from each other, even though they are on the same switch. So the only thing that can affect all of them at the same time is when the attack is on the switch. But if the attack is on one of these systems, it can affect the other two systems here, but it will not affect the system on this other segment. So that is another way to isolate system and create segmentation. So another thing we are going to look out here is a VPN, a virtual private network. So a VPN It's a communication tunnel that provide point-to-point transmission of both authentication and data traffic over an untrusted network. Okay, so that is just the definition. So let me explain it. All right, so we have a VPN server and we have our system, right? And we have a cloud right here. This actually represents internet. And then this green you are seeing here is a tunnel. So how this works is that because organizations can be located from far apart, okay, but they will still want to access the same resources. And then if you want to put all of them in the same network, you have two options. Either you do it wirelessly over the internet or you run a cable. So imagine, for example, a bank, a very big bank in Nigeria, for example, let's say bank A, which is a very big bank in Nigeria, have their headquarters in Lagos, right? And then in Lagos only, they have about 20 branches. In Kano, they have like 10 branches. In Abuja, they have like 20 branches. In Kwara, they have like 5 branches. Imo, they have 10. Different states. So in total, they have about 500 branches in the whole country, in Nigeria as a whole. So now, imagine the number of resources they will now spend if they want to create a network and want to use, if VPN does not exist. So they have two options. Either they connect over the internet and everyone can be able to access their resources, or they find a way to link all their office together with wire, maybe network cable, fiber optic cable, whatever. So imagine the expense of what they are going to spend, right? So it is not visible, it is not tenable, it is not something that can be done. So that is why a VPN is invented. So VPN allows them to communicate, to connect all their branches, all their 500 branches to their head office, to their data center over the internet, the same internet that we are using. They are connected over that particular internet, right? But they are not passing through the route that we are passing through. For example, if you want to access facebook.com, you just open your browser, you put www.facebook.com, wherever you are in the world, you have access to it, right? That is the public internet. If you want to do google.com, you do google.com. If you want to access YouTube, you access youtube.com. That is it. It is open to the public, right? But for bank A, they also have a server in their data center, which is online, right? Okay, but they need their branch in Kaduna to be able to have access to their head office in Lagos. All the branches have to have access to that particular, so that even if you open your account in Lokoja, you can be able to withdraw money in Samfara, right? So that's the same network, and they need the internet to achieve it. But for example, so they also have applications, web applications, whereby they use their browser. Most especially people that have worked in corporate organizations, maybe banks, telecom, and the like. You see that all those websites, the same way you access most of those applications, is the same way you are accessing facebook.com, google.com. But if you put that address on a system that is not connected to the organization environment, so for example, if Bank A have one application that they call www.banka.com, okay, that is hosted within their environment, right? If you put it on your own system that is not connected to the organization, even if you are in the branch but you are not connected to the organization network, if you put that particular website or IP address, in most cases they use IP address and some use website, for those of us that have seen it. If you put that particular web address on your system, you will see that it will not go through. To tell you that that particular website is not reachable. This is achieved by VPN. So VPN creates a secure tunnel within the internet for those communications to pass through. So it's being controlled by what we call the VPN server. So in your branch, there is the system that the router where your communication is going to. They have a VPN client there that they are going to log into before the network is deployed down to other systems in the organization. So that's how it's possible. So it's just like I was saying, for example. So let me just use an example. So let's say we have a road from Lagos to Kaduna, for example, a road, a normal road, general road, everybody can use it, right? So that road is legit. So that's the internet. So but now let's assume, for example, the military also need to move something from Lagos to Kaduna, right? And they want it to be secure. They don't want to use the general road because of the sensitivity of that particular equipment. Maybe if let's assume it's possible for people to attack the military when they are moving, which is quite possible, right? So what they can do is that they can build a tunnel under the road, right? That will also have the same length from the road, and then this can now terminate to different military bases between Kaduna and Abuja, and then and between Kaduna and Lagos, and then whenever they need to go, it's terminated in all their bases. They just go through that tunnel, and then they park, they burst out from their base, and then nobody can see them. They are the only one that will know it exists. So for you to be able to enter the tunnel, maybe you must be a military vehicle, or you must have a particular username, you must have a particular ID, etc. for you to use it. I'm not saying it exists, I'm just giving us an analogy. So that is how a VPN, that's how it works typically. It still uses the internet, but it creates a secure tunnel. Okay, it creates a secure tunnel whereby information pass through securely, encrypted, and then you that you are not connected to that particular environment, you will not be able to have access to it, right? So that is the primary function of a VPN in this context. And then the next one we are going to talk about is defense in depth. So defense in depth is when you use multiple layer of access control in literal or theoretical layers to help an organization avoid a monolithic security stance. Monolithic means one, when you are using just one mode of security, but defense in depth use everything. It applies security to everything, to the data, to the user, to the infrastructure, to the system you are using, to the network, to the policy, procedure. Everything is having at least one layer or more of defense. So I will go to so I'll come back to this slide now. So let me just take a network access control. So network access control is a concept of controlling access to an environment through strict adherence and implementation of security policy. So what a network access control does is that if you have different components of a network, right? In some organizations, you just need to have let's say a level of once you log in, you can have access to different things within the organization. But if you are using a network access control, the network access control is very strict. It uses what we call a zero trust policy. So whenever if you have logged into this application, so for example, let's say an application is hosted here. In some organizations, once you log in, you can have access to everything. You don't need to log in. You don't need to keep logging in before you can. So for example, if you are using an Office 365 application, once you log into your Outlook, you can have access to Outlook, SharePoint, Teams, and all the applications. There are a whole lot of them. Okay, but in a network access control environment, for example, so let's assume a network access environment is or a no trust security policies applied to that particular Office 365. For example, I'm not saying that, I'm just saying if it applies. So if you log in, you'll be asked for your password. If you want to access Outlook, you'll be asked for your password. If you want to access Teams, you'll be asked for your password. If you want to access SharePoint, you'll be asked for your password. If you want to access Microsoft Word, you'll be asked for your password. So that is how it works. So it's more like a no trust policy. It doesn't trust anybody. At any point you want to access something, it asks you to identify yourself. It asks you to verify yourself. If you have to do 2FA, you have to do it. If you have to do 3FA, you have to do more than 2FA, you have to do it before you'll be able to have access to it. So that's how it works. So now let's go back to defense in depth. So just like I said previously, in a defense in-depth security approach is a layered approach when you are designing a security. So you are going to apply a layer of security to everything. So for example, as you can see, we have our data here that are hosted on the service. So this is going to be secured. We have applications that are using this data. You have to secure it. We have hosts, that is people that are using the application. You have to secure them. You have local area network that is used to connect multiple hosts. You have to secure them. Then you have to also secure your perimeter. You have a trusted internal user, your policy and procedure, training awareness and everything. You have to make sure that you are at every instance there is a level of security up to your perimeter. You have to make sure that security is applied on all of them, so that if one is broken, the other one will make sure the other one will cover up. If one is broken, the other one is covered up. So that is what we call defense in depth. So this will serve as a deterrence for many attackers. So when you have a lot of layers of security, it's going to deter attackers, and it will encourage them to focus on other targets, on other easier targets. So once they see that you have a defense in-depth approach in your organization, they will not want to waste their time, because they know if they have to do a whole lot of work before they will be able to break into the network of your organization. So again, this is text explanation of everything for the defense in depth. So you have to secure your data. So you have to apply controls that protect your actual data. So such controls can be the use of encryption. Okay, so encryption, and use your cryptography, you encrypt your data, right? So for example, when you are using your WhatsApp, WhatsApp tells you that your communication is encrypted from end to end. So what that means is that even if someone is able to place him or herself in between the channel in which your communication passed through, they will not be able to make many of them. So remember, in our earlier classes, we've talked about encryption, where we talk about encryption, decryption, and other stuff like that. So encryption is when you convert a plain text or a word, something that is meaningful, you convert it into something that is not meaningful. So there are a lot of algorithms that can be used to achieve that. Another way to protect your data is when we use a data leak prevention. So we have what we call a DLP solution or DLP software. So what they do is that they prevent your data from leaking, right? So what do you mean by data leaking? So for example, we can all see in some situations where we see letter leaking from the military, we see letter leaking from the civil service. It is actually possible because somebody will type the letter, draft it, then he will go and print it, then he will take it, carry it to Oga will read it, make correction, and then he will sign it, and then give it back to someone who is going to scan it and then dispatch it to the various units. So that involves a lot of manual method, and then it's going to be difficult for you to be able to know where the data is leaking from. But if your data is automated and everything is automated, you can have a data leak prevention system which will make sure that all your users have a certain level of security on their devices. And if someone is trying to send out a data that you have classified as secret, right, it's going to raise an alarm to the admin. It's going to block it from happening, right? And then it will send an alert to the administrator of the system that so person is trying to send so data to so email address or to so person, and then you'll be able to trace it back. So DLP helps us to achieve all these things. And then you can see, for example, if you are streaming on DSTV, for example, if you want to do your screen record, even if you record the screen, when you go back to it, when you are streaming on your phone, I mean, not on your TV screen, when you are streaming on your phone, you cannot record the screen. Even if you record it, it's going to be blank. There are a whole lot of your bank applications, they don't allow you to take screenshots of the application. So those are means that you can use to prevent your data from leakage. And also you can also implement identity and access control and data control solutions. And then you can also prevent your application. So you also need to apply controls that protect the application itself from technology. So you can install your data leak prevention again, and then you can have application firewall and database monitor, right? So all this, so if you have application firewall, you can decide which application to run and to run on which system. So if you have set an application not to run on a certain system, the user on a particular system will not be able to use that application, for example. So another thing you need to do is to protect the host. So the host are your endpoint, right? So that's when you apply your antivirus, your endpoint firewall. You need to do your configuration, you need to do your updates, you need to do your patch management. And then also for internal network, you need to apply controls that can protect uncontrolled data flow and user access across the organization level. So you need to apply relevant technologies. We have talked about intrusion detection system before. We have talked about intrusion prevention system. We have talked about firewall, and we just talked about network access control. So these are the solutions that you can apply into your internal network to make sure that all these things, you have a defense index in the organization. And also you can also secure your perimeter. Perimeter is you have physical perimeter, and then you have a logical perimeter, but in this case it's talking about logical perimeter. So that's where you can have your demilitarized zones, DMZ, which we are still going to talk about today. You can carry out malware analysis. So if there's an incident of a malware in your environment, you can analyze it to know what is happening and who is trying to do what. Then you can also have what we call honeypot. So honeypot is also a security techniques, I would say. So what honeypot is that you are going to, so in your environment you can have different servers and different applications running on your server. So if you want to know, honeypot is like a trap. Yes, so it's like a trap to know if an attacker is in your organization. So for example, you can create a server which there is nothing inside. You are monitoring it, and then you can name it maybe financial details or something that will attract, something that will be of interest to an hacker in your organization. Maybe you can say intellectual properties, financial record, stuff like that. So, but there is nothing in it. But the moment you see that someone tried to access it, then you know that there's an attacker is trying to. So you, even if you have not been able to know that someone has been able to penetrate your network, the moment someone tried to access that particular server, you will know that okay, we have a threat. So you can now investigate it to know if it's from the outside or if it's from the inside, and then you now be able to block it. If it's from the inside, you'll be able to trace it back to whoever did it on the inside, and then that person will be asked to explain themselves why they are trying to access sensitive information within the organization. And it's from the outside, you'll be able to know the IP address, you'll be able to know where the attack is coming from, and then you can now block it. So honeypots are just like solutions that you use to trap an attacker, so that you get to know if an attack. It's just like you setting setting trap for rats in your homes, right? So that is what an honeypot does in the network. So it helps you to secure your perimeter. If someone has breached your perimeter, what they are going to do, they might eat your honeypot, and then you'll be able to know if that person, if that car is actually there or not. And then of course you also have to provide controls for your physical environment. So you have to make sure there's physical barrier, there's lock, there's access control on the door, there's biometric, there's security guards and stuff like that. And also you have to make sure that you have administrative controls. You have to have policy in place. You have to have controls that can deter people from committing insider attack, so to detect or to reduce the number of people on the inside that will want to attack your network. And then if they do, you also have policy and procedure in place that will catch them. So maybe you have an auditing system, you have a strong monitoring system, you have an intrusion detection and prevention system if someone is trying to do, or you have a data loss prevention system and someone is trying to do what they are not supposed to do in line with the procedure and policy. It reports them, and then you can now cause them for disciplinary measure. So all these things help the organization, and when you have all these things in place, the attacker, will either insider or outsider threat, will not have the full confidence to attack your infrastructure. So let me try and round up, because we have like 9 minutes more to finish the session, right? So the next thing we have here is the zero trust, which I have explained previously. So zero trust are often micro-segmented network with firewall at nearly every connecting point. So let me get to where the real information is. Okay, so zero trust is evolving that recognize that even the most robust access control have their weakness. So this is where I'm coming through. It insists that every process or action a user must take must be authenticated and authorized. So every action you want to take in the network must be, whatever you want to do, you must authenticate, you must be given authorization. Okay, so because the window of trust is very small in zero trust. So in zero trust system, whatever you want to do, you must authenticate yourself. You must do your authentication before you'll be able to have access to it. So this is an image of a zero trust system. So you have email antivirus, you have email anti-spam, you have user authentication, you have your HTTP antivirus, you have your whatever you are going to do will be subject to test at each level that it gets to. So your personal firewall will check it. You have your network firewall, you have your IP address, you have user authentication. When you are trying to move from here to your file server, you have to authenticate. All these security measures will be applied. If you are moving to your intranet server, the same thing. If you are going to SQL server, this will kick in. You have to go through the network firewall, the network IPS. You are also going to be authenticated again. So you can, as you can see, there's user authentication everywhere within this particular environment. Also, you can see it here. You can see it here, and then it applies everywhere, and then we have different level of security. So what this means is that even if you are authorized, even if you are in the network still will not trust you when you are trying to use different services within the organization. You'll still be asked to identify yourself. You'll still be asked to do your authentication. All this software, all this solution will kick in. They will check the activities to make sure that nothing is wrong and everything is in order, right? So that is zero trust. And then back to network access control. So network access control is actually useful when we have most especially when we have what we call BYOD now in our organization, in many organizations. What BYOD means is bring your own device. Bring your own device in the sense that you can use your phone, you can use your personal phone, you can use your personal laptop that doesn't belong to the organization to access the organization resource, right? So but what do you need to do before you can access all these things? That means there's some level of security that your device need to meet before they will be able to have access to it, right? So all this can be achieved using what we call the network access control, right? There are a whole lot of other solutions that you can use to achieve this. We have our mobile device management solution, the MDM. Different vendors have their own. Microsoft have Intune. I'm not sure what Apple call their own. I'm sure Apple have their own too. I can't remember what they call it, but I'm more familiar with the one for Microsoft or for Azure, which is Microsoft Intune. So they use it to manage your device, so you can be able to know devices that are compliant. You can be able to know devices that are not compliant. But network access control makes sure that you are able to see the device, the who, that is the device that is trying to make control, and what that particular device is trying to connect to, and what that particular device is trying to use. And it became rampant when we started having our BYOD. And also another key trend, or another thing that is most common now, is what we call IoT device, Internet of Things. So Internet of Things devices are our normal devices that normally do not connect to internet before, but can now connect to the internet. So we have our smart TVs, our IP cameras, and then we have internet. The Internet of Things can also be used for all these remember HVAC system, because you need to make them communicate. For example, if your HVAC system is not an Internet of Things device, you cannot be able to control it remotely. But for example, if you are not even in the data center and you are the data center manager, for example, if your HVAC system can connect to the internet or can connect to the network, even though you are not in the office, you can be able to see which AC is working, which AC is not working. You can be able to you can turn it on manually. You can turn it you can turn it on or off automatically from your end when it's supposed to turn off and it didn't turn off, and then you can see it. You can see which one is working, you can see which one is not working, you can see which each sensor is working, you can see which camera is working, which camera is not working, and other stuff like that. So so that's why it's also very important to know, to be able to monitor them, to be able to see what they are doing. And that is why you need to have a network access control in your environment. So as you can see, these are the devices that you may need to use network access control for: your BYOD device, IoT device, guest users and contractors that may need to connect to your network, medical devices, your smart home devices, and stuff like that. So you can use all these. You can have a refrigerator in your office and you can connect it to the network, and you can be able to manage them. And we can turn them on, you can turn them off. You can have your AC in the data center, you can turn them on and you can turn them off. So we are running out of time. I think this should be the second to the last slide. Okay, so yeah, so this is the second to the last slide. So we've talked about this previously. This is just more information on a virtual LAN. So the virtual LAN, it can be on the same switch, it can be on different switch that are connected to each other. And as you can see, the color code represents that these devices are on the same network. So even though they are on the same switch or they are on different switch, we can put them as part of the same virtual network. So you can see we have the red devices, they are on the same network. Alright, so